Hey, ladies and gentlemen, I'm Imelda Ulfistalina Simajuntak from University of Mercubuana. Will be present about impact of various substrate types for total gain that implement in 1x5 microstrip array antenna with H feeder by simulation. Mm, Uh, this is the continuation of my previous work on my 1x5 planar microstrip array antenna with operating in 2.6 gigahertz. The goal is that this method are significantly enhance the total gains or not. Uh, this research implementing proximity coupling across three substrate scenarios and focusing on array vector. Why use proximity coupling? Because we all know that proximity coupling recognized as effective method for increasing antenna gain performance. And then this antenna is required for 5G specification are designed primarily used for affordable affordable material to achieve 5G standard requirements. These research objectives using three scenarios. First, uh, using form lambda divide 2 each patch of the antenna and then using uniform uh, lambda divide 4 and combine lambda divide 2 and lambda divide 4. And the target simulation and the target of simulation is operating in 2.5 gigahertz, return loss below of minus 20 decibel, total gain minimum exceeds 6 decibel, radiation pattern is multi-beam structure, yeah, and then the tools of using the simulation is high-frequency software. The main impact of the gain is using five material of substrate with distance three of the scenarios. This is the motivation is by loss tangent and dielectric constant. If we use the low loss tangent for duroid, it will be achieve the minimal dielectric losses. It means will be higher of radiation efficiency. Uh, it means that we got more higher gain. On the other hand, high Kangen, example like Evercore, will be got the greater power dissipation. It means we will be get the lower radiation efficiency and lower theoretical gain. Nah, the electric constant in physical science, a higher the electric constant will be reduced the wavelength, require smaller patch dimension. Now, crucial point is if a substrate has a higher dielectric constant but also a high uh, close tangen, yeah, like every four, will be get the poor efficiency and resulting will be get the lower overall gain. Conclusion is for high gain will be prioritize material for the lowest possible extension. That's the goal. Uh, before my previous work are 1x5 antenna with used with parasitic patch. Yeah. So one page and then 2, 3, 5 are parasitic, not connect to the feeder, and using proximity coupling, uh, my precious resource. And the result is we get return loss minus 60.76 decibel at 2.42 gigahertz. This is not aligned for 2.6 gigahertz. And then and the total gain result based on radiation pattern achieved two uh, o apa 0.2294 decibel. Now this is significantly lower than 5G standard that we use to achieve minimum of 60 decibel. Now, so the conclusion is we have to optimize from different angle, and this research use new substrate combination to achieve higher result total gain from this design antenna. And then after we use the simulation with three different scenarios, yeah, with substrate for it first is glass and then ever four. The return loss we got is minus 12.316 3196 with gain uh, 10 decibel, lambda divide 4, you subtract glass and ever 4, we got minus 4.2265 with gain total is 5 dBi, and the combination of uh, lambda point 2 and lambda lambda divide 2 and lambda divide 4 with substrate Roger and substrate through L4, we got return loss minus 9.4449 with gain, total gain is 6, eh, 9.6251. Uh, the successful gain enhancement is the integration of proximity coupling and array factor effectively enhance the antenna's performance. The highest achieve use glass and ever 4 substrate combination with spacing lambda divide 2. The highest gain was 10.488 decibel. For the base spacing for the Rogers, the best performance of the combined uh, lambda divide 2 and lambda divide 4 spacing with the Roger and ever 4 substrate, yielding again 6 at 9.6251 decibel. And the first combination is ever 4 and copper are not ideal, as the copper feeder disrupt the transmission and had the poor return loss values. Achieve target because it exceeded the required of 6 dBi, and the current return loss uh, not achieved with the goal was below minus 20 decibel, but the highest reference only achieved in minus 12 decibel. For the future work, we need to conduct further research question on combined lambda divide 2 and lambda divide 4 spacing for the Rogers and Everett subset combination with focusing reflection coefficient below minus 20 decibel and precise operating frequency. Overall, the design is validated and confirmed to have the potential to significantly enhance the gain performance of linear array antenna for the 5G telecommunication application. Thank you, ladies and gentlemen. For the last, I will mention that quote of Mahatma Gandhi that the highest result of education is tolerance. Thank you.